Okay. So in IoT communications, we require cloud computing and other types of computing. So in today's class, we are going to cover three types of computing: cloud computing, fog computing, and edge computing. So in IoT systems, all these computing approaches can become important. So depending on our task, we need to use the specific computing mechanism. We will be talking about fog computing, cloud computing. Secondly, we will start with cloud computing. So in cloud computing, as I mentioned, even in the earlier classes, we do the computationally costly tasks at the cloud servers, where there's a lot of resources. So we know that if we have, for example, an IoT system with some sensors, we can access the network via base stations, and the data can travel through the internet, and it can reach the destination where the data will be processed. So if we upload our data to a cloud server, we can store our data in that cloud server, and we can do analysis of the data as well. So data storage, data analysis is possible with the cloud computing for basically, especially for scenarios where we have large amounts of data, and highly computationally cost tasks. So computationally cost tasks. So these kind of tasks are like uh, okay. So machine learning tasks can be taken as a computationally cost task, which can rather than doing the machine learning task at the sensor level, we can do it at the cloud servers. So the cloud servers uh, are available for provide different types of services. We will talk about that as well. So apart from that, we can do, data storage, data analysis, and we can also monitoring, remote monitoring of the environment. So any kind of a client who is connected to this cloud server from another location can environment where the sensors are. So the customer or the person who's managing the IoT network can monitor the sensors and the kind of the condition of the sensors the uh, from their own location. The sensors could be in this environment. The customer is in another environment, so the customer can access, if the customer can access the environment, access the internet, the customer can access the information regarding the IoT environment from anywhere on earth. So anywhere on earth he can access the data. So basically those are the kind of advantages that are provided by cloud computing for IoT scenarios. So if you have any questions, you can ask. So combination of IoT and cloud computing um, provides us ability to process lot of sensor data and monitor the environment very flexibly and very efficiently. So what happens if we do not have cloud computing services? If we do not have cloud computing available, what kind of challenges will we face? So especially for IoT scenarios where we are collecting a lot of data, if we have a direct communication with our customer, the customer will get a lot of data at a certain time instance. So let's say the customer is connected to this router. So these circles are routers, and the internet is connecting all these routers. And once we send some data from the sensors to the random access network or any kind of other access point, that access point will connect the data to a router, and the routers will forward the data uh, from one router to another router, and the data will be forwarded across multiple routers to the destination node. So if the destination node is in here and the customer is like connected to that node, then customer will receive a lot of data over the time from the sensors directly. So this could be like a problem to the customer if the customer do not have enough resources to process the data and do computationally complex tasks. The customer normally do not have enough resources to uh, process large amount of data and also get some useful information out of those data. So it is important that the customer has a lot of resourceful environment to compute or process the. So in order for us to do that, the customer has to buy the necessary hardware, and he needs to configure the hardware. He needs to install the necessary software, and only then he can really compute or get some useful information from the data that he receives. So because of this, we require cloud computing in almost all IoT applications. Right. So some of the applications of cloud computing are emailing, data management, data storage, data analysis, then remote monitoring, as I said, and running web applications or running kind of some other applications, right? So in here we can write emailing and other applications. So basically we can use the cloud computing to run different applications. So based on depending on the IoT application, we need to create some kind of a web application, mobile applications that can show the user the information. Applications must also be stored in the cloud servers. So I will write NB, right? So we can use these applications in the cloud servers. Stage of emailing and other applications. Okay, so now let us discuss a little bit about the advantages of cloud computing. So we have basically mainly three types of advantages. So we have cost reduction. So the costs for computationally costly tasks, like doing some mathematically difficult tasks, can be done in the cloud servers. So I mean, cloud servers are really very um, capable of doing very advanced computation tasks, and because of that they are able to run the tasks within a short amount of time, and all the required resources are available in the cloud service, and so costly tasks can be done there, and scalability. We can scale our IoT networks uh, in any way that we like, uh, because cloud computing enables us to connect as many as devices as possible. So we can increase the amount of connected devices and increase the connectivity of the network. Increase the amount of connected devices uh, we can connect a large amount of devices. So next we have reliability. So reliability means like how reliable we can how reliably we can do the communication of the data. So specifically, since we are talking about IoT, we are talking about the data reliability, security of the data, and so on. So reliability means like how reliable our IoT network will be once it is using cloud computing. So the data that we send to the cloud servers can be recovered, and can be recovered if it is lost. So data recovery options are available, and data storage facilities storage facilities are available, and also data security facilities are also given by cloud providers. So because of all these and other reasons, we can ensure that the data that we upload to the server, and they are protected. They are protected by any kind of unauthorized attacks and so on. So one student is asking one question. So can we connect sensors to the cloud through Amazon Web Services, since they have cloud computing for IoT devices? So that's a really good question. So we will talk about that further as well. But in here, I will mention AWS IoT. So Amazon Web Services have a separate like a service called AWS IoT, and in this service they are providing us the option to connect our sensor based embedded system to the cloud. So we can connect our embedded systems. So embedded systems means like the sensors, like microcontrollers, plus the communication module. We call this entire unit as the embedded system or the sensor node. So we can connect this all this entity, the entire sensor node, to the so we need to first actually do some initial configuration. um, so after doing the initial configuration, we can connect the sensor node to the AWS. So AWS IoT can monitor the nodes, sensor nodes activities, and we can collect the data from those nodes, and we can display those things, display the data. We can analyze the data, and do the analysis. So it is a very good platform that allows us to use our IoT network, and connect our IoT sensors to the platform. So it will do the we just have to connect our sensors to the platform. The platform allow us to have more functions like data analysis, data management, and so on. Okay, so let's talk about the three service models of the cloud computing. So we have talked about cloud computing before as well, and the service models of cloud computing. So basically, service models means like in what kind of models or what kind of methods the cloud computing can give its service. So there are three main methods. So one is infrastructure as a service. So you can actually we can write in the other order as well. Software as a service, which we call as SaaS, SaaS, platform as a service, and infrastructure as a service. So in these methods, we have slightly differences in how the services are provided. So there are two parties, basically your device and the cloud cloud provider. So in software as a service, uh, your your device actually is accessing the cloud server. So cloud server is the computer that holds um, your data and do any kind of analysis that is requested. So the software and all the related operating systems and uh, computational services are done in the cloud server. So so we are now talking about the SaaS. So uh, in that service, the software, the operating systems, the software, I mean the application, software application, the data is also stored in the server operating systems. The other services that are required to uh, for uh, for the services for the software to run, and uh, all the other requirements are in the cloud server. So we call middleware for the services that provide the connectivity between different applications and functions in the cloud server in order to for your software to run. Then also the cloud server is doing the networking functions, virtualization functions, storage. So these are like fundamental tasks then that are done by the cloud server. So once you are accessing a certain software in the cloud server, the first the cloud server manages the networking, virtualization, and storage of that request. So if any kind of networking has to be done inside the cloud server, the cloud server will manage that networking. Also virtualization. So virtualization is something I have described. So virtualization means like how we can use softwares to do networking functions. So virtualization means like how we can use softwares to do different functions. So the functions are done through softwares. So those functions are included in virtual machines. So virtual machines are installed in some servers. So one server can do multiple tasks. So we can have used to do multiple different activities which are very kind of difficult to handle or achieve. So one server that ability is coming through the virtualization. So the server will be one kind of a hardware unit, and in that unit we have virtual machines. So virtual machines are kind of software programs uh, depicts the functionalities of a computer, right? Of a computer. I mean, it has its operating system, it has its like softwares that a normal computer uh, has to perform its functions. So virtual machines are created using software programs. Anyway, those virtual machines are able to do any kind of tasks like routing, firewalling, and load management, and so on. So I have mentioned about how network function virtualization can happen. And in there, I mentioned how we can install virtual machines inside servers, and those virtual machines can be used to do different network functions, and those network functions can be installed inside these virtual machines using software programs. So basically, by doing this, the one single server can be used to host different virtual machines and do different tasks. So, for example, if one virtual machine is responsible for email handling, other virtual machine could be responsible for YouTube video streaming or some other task. So likewise, a server can be used to hold multiple number of virtual machines, and using those multiple number of virtual machines, we can do a lot of different tasks. So one single server can be used to do very computationally difficult tasks. So therefore, this is the way that cloud servers are kind of built, and therefore, like cloud server is a name that we give for like a collection of servers that do uh, difficult computationally difficult tasks, and those servers are having virtual machines installed in them, and therefore each of the servers can do very large amount of computations. So each of the servers have virtual machines. So each of the virtual machines can do large amount of computations, and um, we can install multiple number of virtual machines in a server. So since the virtual machine is a software, we can easily work with those virtual machines. Because of that, using virtual machines is much more cheaper than using separate servers for different applications. So anyway, so that is how we have the cloud server, and how the cloud server is doing the virtualization. And as you know, a cloud server is used to store data. So that is common. understanding. So basically, once you are using the software as a service, then software is run in the cloud server, and all the data, operating systems, services, networking, virtualization, storage are done by the cloud server. All the actions are performed by the cloud server. So, can you give me an example of software as a service, like where it is used by us? For example, are you using software as a service in your daily life? Because I think it is very something that has become very common. So, I think you could be using that. So, can you give me one example that you are using it? So Microsoft Word is, yeah, you are saying Microsoft Word is something you're using offline, right? So, I mean, in my computer, of course, I have Microsoft in offline mode. However, like if Microsoft allow us to use in OneDrive, for example, we have something called OneDrive, right? OneDrive, right? So this is something we can use in the internet, through the internet. This is something that we can call as a SaaS, right? Yeah. So something that we can use through our internet, and we can access some server in the internet, that we can call as a, software as a service based, uh, I mean, service. Right? So Gmail is one software. This correct. So Gmail is a software that we can use via a cloud server. So Gmail is an application which is available in the cloud server. So we have to access the cloud server, and then we can access the Gmail application. So apart from that, we can also consider that Google Drive and based applications, Google Drive, Google Docs, Google Docs, Google Docs and spreadsheets, Google Sheets, Google other kind of applications, we can call as software service. So when we are using Google Docs, for example, we do not need to have any specialized software installed in our computer. Our computer do not need to have any software installed. We can directly use Google Docs through our internet, and we can do all the tasks that are related to Google Docs, like create, use the directly that uh, tool over the internet. So we don't need to install anything in our own offline devices. I mean, in our devices, we don't have any need to install before using it. But when we are using this service, we don't need to do such things. We can just use the internet. So this kind of thing helps us to save our the storage in our own devices, and so something our device might not lose the data. I mean, if something happens to our device, the Google Docs will still have the data in the software, in the software. So in losing the data if we work with Google Clouds. So basically, that's about software as a service. So we will talk about the next two services: platform as a service and infrastructure as a service. In platform as a service, uh, we have some control over the application and the data. However, the rest of the functions are done by the cloud. in all these three services, these three fundamental functions are happening by the cloud server. So networking, virtualization, and storage functions are done by the cloud server in all these three service models, SaaS, PaaS, and IaaS. So these are fundamental functions. Um, these in platform as a service, the software application and data are controlled by the by the by your own device. So your device will have the application and the data. The cloud server will provide you the operating system, middleware services, and the fundamental services, fundamental functions. So application and data will be controlled by you. I mean, the cloud server hosts your application and data, but you will have the control over the application and the data. So your device will control the application and the data, which is also hosted by the cloud server. The cloud server does not control those application and data. It will host these two items. So application and data will be hosted. So in a platform as a service, web developers and other kind of developers uh, program and create the product that they require. So they are actually developing applications. They are creating application according to the need. So this is required by kind of employees in companies who create new applications. So new applications, new methods of entering data, managing data are done by these web developers. And web developers use the cloud platform to host the building of the application and help in the developing of the application. However, the control of the application and doing changes to the application is under your control. So your company, your device will control the application and how it is built. Basically, that is the idea of platform as a service. Then we have infrastructure as a service, where the infrastructure totally is under your control. So your control, you have under your control, you have the application, data, operating systems, middleware. So any kind of a person in that infrastructure as a service can do changes to the application, can make changes to the data management and how data is stored, can do changes to the operating systems used. They can introduce their own operating systems. um, they can use middleware services that they define. So can the your you have the authority to update and customize the behavior of these components which are hosted in the cloud. So infrastructure as a service gives you the ability uh, to control these elements in the cloud server. So basically you have more control over the items, all these items in the infrastructure as a service. You can change the behavior of of these application, data, operating system, middleware services. So those items will be hosted by the cloud server, but the cloud server will not do any changes to those items, right? So we were talking about the infrastructure as a service. If you have any questions, you can let me know. So next we are going to be talking about the main types of computing. So there are three types of computing, as I mentioned initially. So, so as you think, what is the difference between these type of computing? Have you heard about these three types of computing? What is the difference between these? So, basically, we have different locations where we can do computations, right? So based on the different location that we use to do the computation, we categorize the different types of computing. So cloud computing is done in the cloud servers, right? So cloud computing is done in cloud servers. And so cloud servers are basically stored in a separate data center, which has a lot of resources. So these data centers are consisting of supercomputers, which can do a lot of tasks. So there could be multiple number of supercomputers. We can have millions of supercomputers stored in these kind of data centers, and these data centers uh, hold these cloud servers. So the cloud is these data centers and the servers which hold the data, and yeah, and do the difficult computations. So the data centers hold these cloud servers. So data centers are situated somewhere far from the place where we are collecting data. So cloud computing is done in a separate location, which can be accessed through multiple routers. However, this cloud server could be in another country, for example, and the time that is taken for our data to reach those cloud servers could be high. So in that case, we need to use another type of computing, which is known as fog computing. So fog computing can happen in an intermediate node, which has enough resources to do the computation. So the fog computing can be done in a server, in an intermediate router, or in a server which is in an intermediate location uh, in the communication route. towards the destination. So, so the server that does the computation could be in an intermediate location in the network. So the fog server will do the computation in the intermediate server and do the necessary calculations and give a feedback uh, to the client or the IoT network. So in these fog servers, we can do, if the server is computationally efficient, we can do the necessary tasks in the fog server without going to the cloud server. So fog computing is kind of a uh, is also similar to cloud computing, but it is done in an intermediate location uh, in between the cloud server and the uh, edge. So we will get to the edge. So in between the data collection and the cloud server, we do the fog computing. So the fog servers are in an intermediate location. So basically, it is used to reduce the amount of data um, spent on transferring the data to the cloud server. And next we have the edge computing, right? So edge computing is done at the edge of the network. So the edge of the network is defined as uh, the network of or the place where where the network where the network connects to the devices, right? So this access point, which could be the base station, could have a server in it. We can install a server in the base station related, uh, like control unit. In that control unit, we can have this server also installed, and in that server we can do computations related to the information received by the base station. So if you are doing the computation at the edge server, then we call that computation as edge computing. So uh, that is also another type of computing which is getting very popular. So for applications such as traffic monitoring in the roads, traffic monitoring, and air quality monitoring, any kind of like time sensitive monitoring, we can do at the edge, so that we can quickly do the computation at the edge and give the decision back to the devices in real time. So we can do real time monitoring using this edge computing. So rather than waiting for a considerable time, we can make some decisions at the edge of the network itself. So this is something very important for IoT applications as well, where we require decisions very quickly with low latency, and also where we have high amounts of data. So sometimes when we have high amounts of data, we might not be able to do the decisions so because the bulk of the data is too high. So in that case, we can reduce the amount of data sent to the cloud server by doing the processing at the edge server and sending only the useful data to the cloud server. So that I hope to end today's class and the content related to that. So if you can let me know if you have any questions, I will answer them. So with this, I will stop the recording.